Alright, in this video I want to make sure we are good at completing the square. So I have two different scenarios. One would be a situation where they just want you to solve for x. And the other one is we've got something that we need to graph and that we might need to complete the square to get it into vertex form. And so I do these, it's a very similar process, but I do them slightly differently, and so I want to kind of compare those two. So the first one, I designed these to be a little bit more than basic. Okay, so like the two out front is what I'm referring to. So I'm going to factor that out. Oh, and I meant to move this over to the other side. This gets moved over to the other side. And now notice this is not just x squared, this is 2x squared, and it's not just box, it's 2 box. So what I can do is I can add the same thing to both sides. So I can add 2 box to this side and add 2 box to that side. So, cruising along, I don't know if this is going to work out nicely or not. I'm not overly concerned. So x half of 8 is 4. So 4 squared, and I write 16 in my box. I kind of always go in that particular order. Oh, it's an odd number. Okay, this is 32 plus 3 is 35. All right, I mean, it's not lovely, but so then the next thing I need to do, so notice that if I expanded this out, x minus 4 squared would give me x squared minus 8x plus 16. So now I can divide by 2. And now I can do the cheer, square root, plus minus, and I get x minus 4 is equal to plus or minus, well, root 35 over root 2. I may rationalize that, just because we typically see these rationalized. So I have x minus 4 is equal to plus or minus root 70 over 2. Lovely. Okay, and so x would be equal to 4 plus or minus root 70 over 2. So something like that. And odds are, if you had done this in the quadratic formula, you would have gotten down to here. You would have had 8 plus or minus the square root of 70 all over 2. Notice that this 8 over 2 was that 4 right there. So you can go back and try this one with the quadratic formula and see if you get the same thing. But that's how I would complete the square on that problem. Now on this one, moving it into vertex form, I'm not going to venture over to the other side. I'm going to let f of x stay here by himself. And so I'm going to factor out a negative 2 from these two terms. But then what I'm going to do is I've added now a negative 2 box. What I can do, I can either add it to both sides or I can add 0. So this is negative 2 box. So what I'm going to say is I'm going to do plus 2 box right here, so that a negative 2 box and a positive 2 box cancel out, and so in essence I am adding nothing to that to my equation. I'm adding 0, which I'm allowed to do. Okay, so continuing on. So here you can kind of see the two options of what you can do when you complete the square. Either you add the same thing, this is 2 box and this is 2 box to both sides, or you add and subtract the same thing. So it's minus 2 box plus 2 box that will add up to 0. So this is negative 2 times x plus half of 10 is 5. 5 squared gives me a 25 in my box. That says 25, pretend. And so I have this minus 51 plus 50, and yeah, I did that on purpose. So this is f of x is equal to negative 2 times x plus 5 squared minus 1. So this would be a parabola whose vertex is at negative 5, negative 1, negative 5, negative 1, somewhere here, and it's opening down, and so it's going to do something like that. Let's see the vertex. Negative 5, negative 1. Sorry, that was the end of some lunch or something. I don't know. So I hope this is helpful. Make sure that you're comfortable using this, because we'll see this a bit when you need to solve equations, and you'll also see it when you need to change something to move from standard form here to vertex form here. All right, practice, practice, practice.